thanks all of you for joining us here today. This is let's say a little bit different press introduction than what we've always done in the past, where typically we have all of you come to visit us here in our factory in MV Agusta or at some location around the world to try our bikes. Obviously the situation in the world today with what's happening, we've had to try to adapt new technologies. And that same philosophy of adapting and technologies is also transferred over into what we're doing with our products. Inside of MV Agusta in the past 5 years, not only have we been looking at bringing new technologies directly to the bike and let's say bringing those technologies to the press or to our customers, we're also pushing the boundaries inside of MV Agusta, looking to adapt and apply new technologies in, let's say, our thought processes, in our internal procedures, in our engineering department, in our marketing department. The last 5 years has seen another industrial revolution. And that industrial revolution means that the technologies are changing so quickly that we have to keep pushing not only to apply existing technologies, but also to keep pushing to learn and adapt to new technologies that are coming out every single day. And those technologies for what's regarding, let's say, R&D, are not only in the design tools that we use, but also in the design methods and the laboratories and the equipment that we have available to us to develop the motorcycles, pushing limits even further and faster than we've ever been able to do in the past. And with the Brutale 1000, what that meant was we spent over 170,000 hours with this motorcycle inside the virtual world. It's like an avatar, an engineering avatar of the Brutale 1000 RR, living inside of our design models, where we're looking at the CFD with the computer-aided analysis for the aerodynamics, whether we're looking at noise, vibration, performance analysis inside of our computers. We're able to do, let's say, much more today with the tools that we have available and what we've been investing in the company, not only in the products, but also in our research and development laboratories. It's been a very dynamic 4 years here inside of MV Agusta with regards to adapting new technologies, new tools, and new mentality. And why do I say mentality? Because the Brutale RR is born from a completely new mentality inside of the design and development area. And it is tied in together with the styling department from the very beginning. The very initial concept of this bike was born from a new mentality. And that new mentality inside of the company is not only absolute power, being the most powerful hyper naked bike that's on the market, but from the mentality that we need to be able to make this bike, let's say, much more approachable to all of you, to all of the riders. And it doesn't matter of the level of the rider, whether you're let's say, a world superbike caliber rider, or you're new to the MV Agusta world and you're just starting out on an MV Agusta product. We want to make sure that our bikes are bikes that never make it difficult for our riders to get on and to start exploring the bike. So it's an experience together with the rider on the bike to be able to take you, let's say, through the growth as a rider, to push your limits, but never feel that the bike is putting you in a difficult situation, whether it's due to the electronics that are aggressive, or the chassis setup that's aggressive, or the ergonomics on the bike that are aggressive. So we looked at all of these different things to make sure that what we're doing every step of the way, from the design to the ergonomics to the very beginning of the vehicle development, to make sure that we're, let's say, rider focused on everything we do inside of MV, to bring an experience to the rider that is always pleasurable, whether you're on the Misano racetrack, whether you're going up to Stelvio, up on the tight mountain roads, or you're in the center of Milan and you're going to get an aperitivo. We want the bike to be a pleasurable experience and all of the wide-ranging, let's say, applications that you can do with this bike. So it's made it a lot more difficult, because if we were looking just to make a naked superbike that could do the fastest lap time at Misano, it's a single focus, and it makes it very easy to work on that single focus. Opening up our horizons and making sure that we're including the entire riding audience, all of our potential customers, in all of the possible situations, it's a much more complicated task to do. because from an ergonomic standpoint, we're looking at different sizes of riders, taller, shorter, and different builds of people, and making sure they can all fit on the bike and fit on the bike comfortably. And when we're riding the bike, we want the connection between the rider directly to the rear tire, not connected from the twist grip to the engine, not connected from the twist grip to the throttle bodies, connected from the twist grip directly to the rear wheel. So that when you're opening and closing the throttle, you feel exactly what you're asking for. You're asking for a lot. It's a direct connection. There's no delay, and there's no harshness to that feeling. So it's also a tough balance to find something that is smooth yet direct. So we spent a lot of time in all of these particular areas to make sure that we're able to bring a product that's much more mature, much more dynamic, and much more open to a much bigger audience in all of the situations that the motorcycle could be applied to. So going from a general idea of where we were going with the Brutale 1000 RR, I'd like to go into a little bit of detail and maybe give you a little bit of backstory on our development process and how we came to the point that we did with this incredible bike. So starting off with the Brutale 1000 RR, what we'd like to do is first show you a video, and this gives you kind of a dynamic idea of what we were trying to do with some of the electronic packages, above all on the electronic system, which is the most advanced electronic system that we've ever put on a motorcycle in MV Agusta. And after we go and show you this video, then I'll go into detail in specifics. Thank you. So what we were able to show in this very short video was just a quick flavor of some of the electronics package that we put onto the Brutale 1000 RR, where you saw Davide Stirpe, one of our test riders here in MV Agusta, and Andrea Fondrini, one of our engineers from the electronics department, also working on our new app, MV Ride app, which I'll go into in a little bit, to build an experience around this bike. What we're really focused on with the Brutale 1000 RR is really generating a new rider experience, not only the bike, but everything around the bike and also the virtual environment that we then put into our users' hands, into all of our customers' hands. And in MV Agusta, we're really focused on, one, examining the past to know what we've done well and what, in a lot of cases, we haven't done very well. And by re-examining that, we're also able to look into the future and inside of ourselves to understand what we need to do to improve. And in the past, in MV Agusta, we've always been the most beautiful motorcycle, period. Motorcycle art. There's no question about that. In a lot of cases, we've had the most outright performance in terms of horsepower. But what we have maybe in the past, and also less than maybe, what we've not been very good at in the past is bringing all of these things together to make the motorcycle something that works in every condition. Maybe the MV Agustas, the Brutales in the past, you would take it to the racetrack and you would understand why the Brutale exists. But when you were driving around in the center of the city or maybe on B roads, you would think to yourselves, you know, it's great on the racetrack, but maybe MV Agusta forgot about this one aspect of riding that is where 90% of the people are riding all the time. So we had to change our focus. And by changing our focus doesn't mean changing the level of the performance. It means making that window of performance much bigger. And what we wanted to do was not lower the level of absolute performance of the bike, but make it in a way that anybody that gets onto the bike, whether they're a champion or a new rider, immediately feels comfortable on the bike. Because the comfort builds trust. And when you have the trust, then you as a rider, you can start to push the bike to start to explore your limits. It's very difficult to find the limits of any modern sport bike today, whether it's MV Agusta or the competitors' brands. The limits are so high. The grip available from the tires is incredible. The brakes are incredible. It's very hard to take a rider and get the bike to push it to that limit. But it's very hard to generate a trust between you and the bike where the rider is able to grow. And by the growth of the rider, it also generates the attachment between the owner and the motorcycle. So we focused a lot on this, which is a complete change from where we've been in the past as a company. And the Brutale 1000RR helped us grow as engineers. It helped us grow internally with all the staff, everybody that had a chance to ride the bike through the development stages as we continue to re-examine where we were and where we were going with a common focus in mind. Now, how did we get there? We get there with, let's say, having very defined pillars from the very beginning of this project. And the pillars from this project, from the very moment that we were going to put pen to paper, were hyperbike performance. MV Agusta is maximum performance. This bike started its development cycle almost 4 years ago now. There was nothing in the naked category that had over 200 horsepower when we started this project. So we knew we wanted to have maximum performance, over 200 horsepower. Ease of use. This is something I've mentioned a few times now. We wanted to change the focus here to bring the bike to the rider and start to generate this trust. Super premium components. MV Agusta with a, let's say, halo product like the Brutale 1000RR. We need to not only bring our engineering experience together, but all of the, let's say, the top component manufacturers in the world, whether it's Brembo brakes, Olin suspension. We need to bring all of these partners together to make sure that we're amalgamating this product and bringing everything up to the same level. And transparent electronic systems. And I'll talk about this a little bit more as we get further into the presentation. Electronics, from my personal point of view, are something that are like the secret police. The secret police in the aspect that you want to know that they're there, but you never want to see them. A truly refined, functional electronics package is something that's working so well that you don't even know that it's there. It's so transparent. The traction control is not generating any problems with vehicle dynamics. It's not generating any pumping on the back tire when it starts to go in. The wheelie control or front lift control in our case is not generating, let's say, a galloping motion of the bike. So it's something that works so fluidly, so seamlessly that it's almost transparent. It's working in the background. So this was something that we had to have an initial focus on from the very beginning to make sure that our electronics department was working in this direction with all of the aids that we were putting onto this bike. So starting out with the Brutale, we obviously start with the engine. The heart of the Brutale 1000 is the four-cylinder inline 1000. Something that in MV Agusta we were a pioneer of bringing the 1000cc inline 4 with a center cam chain. So the cam chain, if we go back to the image here that we were showing on the screen a moment ago, you can see in this image everything that is red is new inside of the Brutale engine. And we are the only four-cylinder engine manufacturer in production today with MotoGP technology in the way that we have a center cam chain. The cam chain that's located in the very center of the engine means that we have two very short camshafts controlling cylinder 1, cylinder 4. And what that does is helps us reduce the torsional reaction of the camshafts and allows us to have more control, very precise control over the valves at very high RPM. So this is something that is specific to MV Agusta. The location of the generator. The location of the generator of the engine is not as it is on typical four-cylinder engines on the end of the crankshaft. We have the generator located up and behind the cylinder bank, which brings the inertia of the crankshaft, which is quite the heavy part, and it's also spinning quite high, so it has a lot of momentum of inertia, located very close to the center of gravity of the bike. So by having that located up very close to the center of gravity of the bike, number one, it reduces the width of the engine quite a bit, and number two, it helps with vehicle dynamics, because by having that closer to the center of gravity, it brings that very close to the center of mass of the bike. When you're going into the roll of the bike, it makes it quite a bit easier to go from full left to full right, or even get the bike down into a corner. Another important aspect of the bike, if we go back to the image that we were showing a moment ago, is with the oil system. So the oil system inside of the Brutale follows a concept. We can do two things. We can go into the combustion chamber, into the intake track, and into the exhaust, and try to force more power out of the engine, or together we can make more power in the combustion chamber and then work very hard to lose less power in the parasitic loss. And the Brutale 1000 engine had, let's say, a two-pronged approach. Number one is to make a lot of power in the combustion chamber, and number two is look at every single aspect after the combustion chamber all the way to the rear wheel to reduce parasitic frictional loss. And we did that by studying the friction of the piston rings, by studying the shape of the piston and the profile of the piston to reduce the friction between the piston and the cylinder walls. We did that by looking at the bearings between the connecting rod and the crankshaft, the treatment of the nitriding on the crankshaft and the surface finish on the crankshaft. All of the gears from the crankshaft all the way through the transmission have been completely revised. We've changed all of the profiles and all of the surface finish on those gears for two reasons. One, to reduce friction, and number two, to reduce noise. By reducing the friction and reducing, let's say, the free play between the gears, we've also been able to reduce the noise, which I'll get to in a moment, the important aspect of that. So we've looked at generating more power inside of the combustion chamber and reducing the loss of the power from the combustion chamber all the way back to the rear wheel. Inside of that is the oil system. The oil system inside of this engine is very important for two reasons. Number one, with the high RPM and the high power, it's very important to have the right amount of oil in the right spot. It's not about having oil everywhere inside the engine. It's about reducing the amount of oil that we're pumping everywhere inside of the engine to get just the precise amount of oil just to the precise spot to make sure that we're lubricating that area in the way to increase the reliability and in order to give us the reduction in friction. At the same time, what we're doing is pumping less oil. And by pumping less oil, we have less parasitic loss of the oil pump, trying to force that oil through the entire oil system all the time. It helps us reduce the oil temperature. By reducing the oil temperature, it also helped us reduce engine temperature, which means the water temperature then is lower and the bike runs cooler. So we looked at everything, bringing it together as a system to make sure that we're also increasing, let's say, the pleasure, the riding experience on the bike by reducing the overall temperature of the bike. So it had a lot of, let's say, positive aspects looking at the oil system. We have a unique system, which is a splitter inside of the image we were looking at before. You can see that there is a horizontal splitter in red, we'll see it here in a moment, between the oil sump and the rest of the engine. Inside you can see the red plate there that's just above the oil filter down by the bottom of the engine. That's an internal splitter that helps us reduce the sloshing of the oil back and forth under hard acceleration or hard braking. And how can we explain this? If you go to the beach and you're running on the beach, you can run at your full speed when you're on the sand, right next to the water. The moment that you go into 1 centimeter of water and you start to run, all of a sudden it's a lot harder to run at your speed. That's because you have the hydraulic loss of energy between your feet and the ground. The same thing with oil. When you have a lot of oil inside of the engine, going on all of the gears, going on the transmission, going underneath the pistons, and going everywhere, that's taking out energy. that energy is basically power, and you're robbing power and turning that energy into kinetic energy of the oil, raising the oil temperature, and then losing power effectively at the rear wheel. So we looked at this from two aspects: increasing power in the combustion chamber, reducing the loss of power all the way back to the rear wheel. So this was an important aspect in making the power. The other thing in performance is power and weight. We looked at everything on the Brutale package to make sure that we were not only increasing the power, and you can see here in the power and torque curve, we have a very linear torque curve for an inline four-cylinder engine, and this very linear torque curve also translates into ease of use because when we have a torque curve that is without peaks and valleys, that allows us then with the electronics, the rider aids, to make it much easier to come on top with the electronics and make sure that we're not trying to control the power when we're coming up on a valley, control the power when we have then an increase in the torque. It makes it much smoother and much easier for us to even things out and then give a much better rider experience and connection effectively from the twist grip to the rear wheel. So when it comes to the power, we have two things going on with intake and exhaust. Number one, the Brutale 1000RR inside of the airbox, which is made out of complete carbon fiber. Even the parts on this bike that you don't see are carbon fiber. So the airbox, which is underneath here, is a fully pressurized ram air airbox. We have two intakes on the front of the bike, one on the left and one on the right, which are direct ram air intakes into the airbox. And inside of the airbox, we spent a lot of time with CFD, computational fluid dynamics, looking at pressurization and flow inside of the airbox to make sure that we could even out the torque and the power at all RPM ranges and all speeds. Why is that important? Because looking at a lot of data coming from our World Superbike experience, in the past we invented a technology with variable length intake trumpets. And while that was a system, the TSS system, the torque control system, torque shift system, allowed us to increase the torque at the bottom end, we came to a point now with the power and the torque that we're able to generate with the Brutale 1000RR, where we were generating extra torque with the TSS system, and at the same time we had to cut the torque in order to control it, because the bike is always trying to wheelie over backwards. So we had, let's say, an excess torque situation being generated, which was we're spending a lot of energy in putting extra weight on the motorcycle with the TSS system, which weighed about 1.2 kilos, while at the same time we had to come in with the electronics and cut it because we couldn't use all of it. So what we then developed with the Brutale 1000RR is a new system with variable length intakes that are fixed, but at the same time give us a very smooth intake, let's say harmonics, tied together with the exhaust harmonics that we studied quite a bit with the fluid dynamics inside of the engine, to make sure that we have all of the signals, the pressure signals from the exhaust and from the intake, as smooth as possible to give us that smooth torque curve, the maximum torque, and at the same time allow us to remove 1.2 kilos from the motorcycle. As you all know, F equals ma, as Newton taught us quite some time ago. Force equals mass times acceleration. So by reducing the mass, it's giving us extra acceleration due to the same amount of force. So it's also a very important, let's say, ethos inside the design and development of the Brutale 1000RR. Moving on from the engine, we have the chassis. The Brutale is, as Giorgio mentioned previously, is the third generation Brutale, a four-cylinder bike. So this third generation Brutale four-cylinder bike has some key elements that are Brutale and will always be Brutale. Those elements are the steel chromoly trellis frame, which ties the steering head to the cast aluminum side plates. Our cast aluminum side plates also have an adjustable swing arm pivot where we can move the swing arm pivot up and down to change the chain torque and change the dynamics of the rear suspension of the bike depending on the riding situation or the rider preference. Also inside of the MV Agusta, we have the adjustable linkage on the rear shock absorber, which has the adjustable pull rod, so you can change the ride height of the bike without changing directly any other suspension components. You can very quickly change the ride height of the back of the bike. Changing that changes the dynamics of the bike. You can change the steering head angle by changing the ride height, change the squat of the bike, directly without having to change any components, and it's very quick and easy to do for somebody that takes the bike to the racetrack and wants to adjust the bike, fine-tune it for the riding style or for the conditions of that day. Other aspects that are Brutale are, without a doubt, the Brutale front headlight. The full LED front headlight on the Brutale is a shape that has become, let's say, iconic of this bike. The front headlight on the Brutale is something that was there from the original Brutale first generation. There's a backstory behind this. We've probably explained it a few times in the past. When Claudio Castiglioni was driving down to the CRC Design Center in San Marino 20 years ago, as he was going down the A1 expressway here in Italy. At that time, there was no Autovelux, so it was basically a racetrack from Varese all the way down to San Marino, about 400 kilometers away. And the entire time that he was going down the Autostrada, he had a Porsche GT3 that was behind him, pushing him down the Autostrada. And when he was looking back in the mirror, he saw the shape of the Porsche headlights and fell in love with that shape. And we were able to take that shape, develop that shape, and apply that shape of the front headlight to the very first generation Brutale. And it's something that has become iconic to the line, to the shape, to the form of the Brutale from the first generation to what is this, our third generation of the Brutale. So moving on from the design side, we have the premium components. As we mentioned before, Öhlins. The suspension system on the Brutale is full Öhlins electronics. So it's the EC NIX 43mm front forks with the TTX EC rear shock, which is located down here, as well as the Öhlins EC steering damper. The Öhlins EC steering damper is full automatic, so we're adjusting, tuning the steering damper live while you're riding the bike, where the suspension on the bike, front forks and rear shock, are adjustable with riding modes and adjustable with the app for the settings. What we've found inside of MV Agusta when we're riding the bike, in order to build trust, what you don't want are things that are changing while you're riding the bike in a performance bike. So with the Brutale, when we were in the development process of this bike, and we had, let's say, suspension that was full active, and the suspension is changing as we're riding the bike and with the conditions, and we had a little bit of a disconnect between the feeling of riding the bike and what the bike was doing, the harder that we were pushing the bike. So we made a conscious decision in the very beginning of this project. We want the electronic suspension because we want to be able to tune the bike for the conditions. We want to tune the bike for the rider preference. We want to make it easy to tune in the rider modes that you can tune in the dashboard. But what we don't want is the suspension changing while you're riding the bike without you being aware of it, in order to make sure that we're giving you the same feedback every time in all the conditions so that you can generate more trust, more feeling with the bike. So moving on with the bike, the brakes, of course, are Brembo. We have the Brembo Stilema calipers on the front, and we have the Brembo radial pumps both for the clutch and for the front brake on the Brutale 1000. So we have top-line components with the suspension, top-line components with the brakes, and the wheels are forged aluminum wheels, and the tires are top-of-the-line Pirelli Super Corsa, the SPV3. The headlights on the front is full LED. Not only is full LED, but it's also cornering, so it's tied in with our 6-axis IMU sensor. So as the bike is changing lean angle, going into roll into the corners, we're activating or disactivating the LEDs on the light to increase or decrease the view of the headlight through the corner. So we're driving the light through the corner where you should be looking, to help the rider focus on where the light is going and drawing their attention deeper into the corner at night as they're riding the bike. So it's not something only to illuminate the road, but it's also as a rider aid, because where the light is the brightest tends to draw the rider's attention, and it's driving the focus of the rider to look where we feel they need to be looking to be as safe as possible, and that's looking through the corner, through the apex, towards the exit of the corner, and not outside of the corner as they're cornering at night. So it's an important aspect, not only for, let's say, to generate more light, but also to get the attention, the focus of the rider where it needs to be safe. The rear tail light is a full LED rear tail light. As you can see here, a very iconic light guide inside of the rear tail light, which is full LED. And the turn signals as well on the bike are full LED. So we have the full LED turn signals on the front, and the very unique turn signals on the rear, which are tied in directly to the license plate holder. So, moving on from the premium components that we have on top of the Brutale 1000 RR, we'll get into the next stage of the presentation here, which are the electronics. Now, the electronics on the Brutale is a generational leap forward for what we have in MV Agusta, not only from the interface, which is a 5-inch TFT screen. The 5-inch TFT screen on the bike is the interface between the electronics package, which is behind the bike, and what we have also in the app of the bike. So, how are we working with this? Inside of the TFT screen, we have, as you can see, a bunch of different menus. We have the traction control, we have the inertial sensor. I want to talk about this one moment. If I lean the bike a little bit, you can see that it starts to change the degree with lean angle. We have a 6-axis IMU sensor located in the very center, very close to the center of gravity of the Brutale 1000. And this is the core of our electronic system. And when I say core, I mean core in terms of data, the data that it is generating. The data that this information is generating is controlling what we're doing with all of our rider aids and all of our packages on top of the general algorithms for engine control, fuel injection, spark, and so forth. And what we're doing with this inertia sensor is rather unique. Because what we're doing with this is something different in terms of electronics. Where in the past, MV Agusta has been focused on traction control, trying to find traction and maintain traction. Our philosophy has changed. It's changed in the way that we're not looking to find traction. We're looking to control slip. And at the same time, we have launch control on top of that. And when we go into what you can see here on the screen right now is a data acquisition trace of a launch control. On the top, what you see is engine RPM. The second band is throttle position, so you can see that it's a step function. Basically, the test rider in Ilario Dionese, in this case, our test rider in R&D, held the throttle wide open. What you can see in the third graph, the red line, is the throttle body, the throttle position. So while the rider is requesting full power, we're controlling the RPM with the throttle position of the throttle bodies, which are in the center part of the motorcycle. So we're controlling the throttle bodies, you can see right here, right there. We're controlling the electronic throttle bodies with the engine control module, and as the rider lets out the clutch, and that's the sensor on the very bottom of this graph, you can see the clutch switch came out, the rider gave out the clutch, and at that point, the fourth line down, you can see the acceleration, the vehicle speed. And during that vehicle speed, the front tire, you can see, is trying to come off the ground slightly. You can see that there's like the little V's coming down on the graph that's showing where the front tire is trying to lift off the ground, and we're controlling that with front lift control. At the same time that the rider is keeping the throttle position wide open. So in the entire launch sequence, the rider is focused only on keeping the throttle twisted all the way open. While he's twisting the throttle all the way open, the only thing he's focused on is looking forward and shifting. We're controlling the rest. We're controlling the torque, we're controlling the acceleration, we're controlling the lift of the front of the bike. And we're doing this with an algorithm that's based on acceleration. So we know the attitude of the bike. We know how the bike is positioned on the ground with the inertia sensor. We know when the front tire is starting to come up off the ground, and our engine control strategies are torque based. So we know exactly how much torque we're generating with the engine, what gear we're in, and the position of the center of gravity of the bike. And we're controlling the balance between the mass of the bike and the center of gravity of the bike trying to pull the front down, and the acceleration of the bike and the mass of the bike trying to wheelie the bike over backwards. And what we're doing is balancing out that torque coming from the rear tire, from the load on the front tire. We're controlling the acceleration inside of that window, so it's an acceleration-based system. It's not a RPM-based, it's not a lift control-based, it's an acceleration-based system. And with that algorithm, what we can do is guarantee the maximum acceleration in all conditions, whether you're on an incline doing launch control, whether you're going down a hill on launch control, if you're on flat ground. We can control that by having the acceleration target, knowing the position of the bike, knowing the position of the center of gravity, and knowing the torque that we're generating in that situation. So it's an important, let's say, philosophical leap, rather than just trying to control power, trying to control the acceleration. Another important point with the electronic system that we'll go to here in just one moment is the front lift control. This is different than anything else on the market. What's on the market now is a wheelie control. MB Agusta doesn't have wheelie control. We're controlling the front lift. What we don't want with our electronic systems is to generate a situation where you're not enjoying the bike, something that has a negative impact on the riding experience of the bike. What we want with the bike is to make sure that the rider is at the center of what's going on. And I spoke about this a little bit before with trust. And trust, and there's another thing that comes into play here, and that's self-preservation. Because when you have a bike that's generating over 200 horsepower, and you're trying to hold the throttle wide open, and that power is coming on, not only is it about making the wheelie come up in a smooth way, maintaining the altitude of the front tire, and trying to draw that wheelie out in a controlled way. What we want to stay away from in any case is the front tire that's continuing to go up and down, because then you start to have load transfer. And during those load transfers, you're loading and unloading the suspension. If you're coming out of a corner, for example, the Carro, one of the last, the third last corner of Misano, you're coming out of the Carro, you open the gas all the way, you're bringing the bike up, the bike is starting the wheelie, you're clicking the next gear and trying to tip the bike into the left. If you're controlling the wheelie and the bike is starting to have load transfer, at the same time that you want to tip the bike into the left, you're in vehicle dynamics that are making it difficult to hit the apex as you turn into the next corner. So what we want with the bike is as you come out of the corner, it starts to wheelie, it maintains an altitude of the front tire, and when you're ready to brake and turn in, you're in control, not the vehicle dynamics that are out of your control. So we focused a lot on this, and during the first testing phase of our front lift control, and this is where self-preservation comes in, we were working very hard on this, trying to make it as smooth as possible, as easy as possible. And when I was riding the bike with our electronic engineers and with Ilario Dinesi, I got onto the bike for the first time after they'd been working on the front lift control and had a chance to test it, and came out of a tight corner, full gas down a straightaway, and I pulled off after a couple laps, came in and congratulated the electronics guys. I said, wow, this is incredible. I came out of the corner, I was able to hold the throttle wide open, second, third, the front tire came just off the ground and maintained it, and pulled me down the straight. And the electronics guys were downloading the information from the data acquisition, and as all electronics guys like to do, they like to tell you everything that really happened, not what you think happened. And we looked at the data, and they said, you know, you think you were wide open with the throttle, but you weren't, Brian. You were actually, if you look at the data, you can see that as the front end was coming up, I actually slightly closed the throttle. And in my mind, I was convinced I had the throttle wide open. But really, it's true that I'd closed slightly the throttle. And it made us think about it even more. The wheelie control is not only about holding the altitude of the front tire as you're riding. It's also the pitch rate, how quickly the bike is coming up into a wheelie and holding that wheelie, because it's the initial pitch rate that generates trust. And we, looking at that data and speaking together and trying to develop, let's say, our philosophy around this, we realized we had to work hard to develop a pitch rate that generated trust. Not trust just for me riding the bike, but for everybody else that got onto the bike. And it took us quite a bit of time to overcome, let's say, the self-preservation principle, because with so much power, and even with the clear idea that I had the electronics, I was in a controlled situation, I was on the track, I was convinced I was holding the throttle wide open, self-preservation came into my mind, and it made me slightly close the throttle. And we worked very hard around that principle to make sure that we're developing an algorithm that isn't just controlling the pitch in of itself, but also the pitch rate and how it's coming up, the rate that it's coming up where the rider feels confident that he's in control. Not that the bike is coming up quick and then stopping. They feel like they're under control the whole time. So, like I said, the bike was designed around the experience and building trust with the rider. And this is one of those important points. Moving on from that, we also have the traction control with, like what I mentioned previously, is more slip control than traction control. And you can see that in this data trace that we have here. Again, in the top you have the engine speed. You have the twist grip, which is the second level. You can see that the rider was holding the throttle wide open at a certain point coming out of a corner. You can see in the third graph, that's actually the throttle body position. In the fourth graph, you can see the vehicle speed, and you're looking at front wheel speed and rear wheel speed. And you can see that at a certain point, about a third way down the graph, the rear wheel speed starts to go higher than the front wheel speed. And what that means is we're controlling the slip. At that point, the back tire is starting to slip. Down when you go into the traction control phase and the very last bar of the graph, you can see that we have the initial actuation of the traction control where we're controlling the situation, and then we start to control how much slip we're allowing, because slip is drive. And controlling the slip also allows us to have a bike that if we start to cut torque to the back tire, we start to again regain grip. Regaining the grip, we start to have load transfer, and in the middle of the corner, we start to have pumping. And what we don't want, again, is vehicle dynamics that are being subject to electronics. We don't want the electronics generating vehicle dynamics that take away from the experience of the bike. So we worked hard to have a seamless slip control rather than a traction control. We're not trying to take you from a slip situation all the way back to a traction situation. We're trying to enter into a slip situation and then maintain that slip, and maintain the amount of that slip depending on the level of TC that you've chosen inside of the dashboard. That can be from 1 to 8 or 0 if you want to go to TC0. So you have the opportunity to control how much slip is going into the back tire in order to make sure that you're maximizing your drive coming out of the corner, while at the same time reducing the negative effects of the impact of the electronics on the rider experience. And this is something where as we got further and further into the development process of the electronics on the bike, the riders themselves were coming off the track saying, I'm not sure if the traction control is on or off, but I'm able to drive so hard out of the corner. And when we're going to the corners to see what's happening, and we're leaving big black marks, acceleration coming out of the corners, but it's so seamless going into the slip while you're in the slip situation, and coming out of the slip situation as we're controlling the torque application with the EMU sensor as you start to straighten the bike out and drive out of the corner. So it's about having that as transparent as possible in order to make you feel as safe as possible in all situations. So there was a tremendous amount of focus on this, let's say, mentality of making the electronics the secret police around the bike rather than something that's evasive inside of the rider experience as he's riding the bike. Another important aspect, revolutionary for the MV Agusta Brutale 1000, is the application of the MV Agusta Ride app. Inside of the Ride app, we went in a complete new direction to not only bring the rider experience closer to the bike, because there's an important part of the Ride app that increases the rider experience with the bike experience through the dashboard and through the interaction between the rider's smartphone, handheld device, and the motorcycle, with all of the custom maps, where the rider themselves can generate their own custom maps inside of the menus very easily. We saw it in the video at the beginning of the technical explanation. Very quickly they can make their own maps. They can make their own maps. They can save their own maps. They can give that map a name: Misano, Mugello, Stelvio, Futa, Pikes Peak, wherever you are that day, whatever you used with the suspension settings, with the engine control settings, with the traction control settings, with the front lift control settings, whatever map you generated that day, you can save it, you can give it a name, and it becomes a menu of your custom maps built inside of your smartphone and connected directly to the Brutale 1000. And this application is not only about bringing the rider closer to the bike, it's also about bringing the riders closer together themselves. The second pillar of the MV Agusta Ride app is about community. And inside of that community, you now have the possibility in the Ride app to register your ride. You can register where you've gone inside of the app, your trips, what you've done that day, your lap times at Misano, your lap times at your racetrack, and the routes that you have taken. And you can share those routes through the MV Agusta Ride app with the rest of the MV Agusta Ride community. So you can say, I went to Misano, I used my app, the Brian custom map that day, and I thought that this worked the best for me this day in these conditions. and put that out on the MV Agusta community and let them try the app. You can share this, you can increase your ideas, share your experiences with the bike. So it's an important part not only to increase, let's say, the interaction between the rider and the bike, but also the community themselves. And we're very focused on what we're doing with the community. This is a first step of the MV Agusta Ride app that we're rolling out now, and it's something we're going to continue to expand upon in the future. We see this as a very important part of our development path, technological development path for the future. So it's something that we'll be continuing to work on in the future. So if there's some key points I'd like to all of you to take away from hopefully soon when you have a chance to ride the bike and the opportunity to go out into your favorite roads or your racetrack to test the Brutale, is to feel what we've worked so hard on in order to give the Brutale, let's say, a Dr. Jekyll and a Mr. Hyde experience. We tried to make the bike very easy, very controllable, very smooth, low to mid RPM, before you build continuously into an incredible top-end power and incredible acceleration. So we wanted to make the bike as user-friendly as possible, while at the same time inviting our riders to explore and push their limits inside of their experience with the Brutale. So this is a very important point in trying to make the bike very smooth, very easy, very controllable in all situations, in the inner city, on B roads, onto the racetrack. And then when you have the opportunity in controlled situations, try to explore your limits as a rider, because to find the limits of the Brutale, I can tell you, even with very top-level riders, is very hard to get to where the limits of this bike are. But push those, explore those, and test out the custom apps, test out those settings in order to increase your experience with the Brutale 1000RR. So I understand this is a different situation here today, doing this virtually. I hope I was able to explain and try to give you a little bit of backstory with where we're coming from with the Brutale and where we're going inside of MV Agusta as a company with our philosophy. So thank you for joining us. If you have any questions or you'd like to add anything, all of us here would like to hear what your thoughts are. And more than anything, we really look forward to hearing back your comments after you've had a chance to test the Brutale. I know they're going out to the distributors and to the area managers here as we speak. So please contact your distributors, your local distributor, your local area manager, and book or test ride on the Brutale 1000RR. Thank you.